Hello students, in this session we are going to see testing the consistency of a non-homogeneous linear equations. Let's see what is non-homogeneous linear equations by having some examples. So in this slide left side you can see example number 1, and that is the example for non-homogeneous linear equation in two variables. So let me explain stage by stage. So I have given two equations in this example. In both the equations you can see the power of x and power of y as 1. That's why it is linear. Okay, and in both the equations you can see we have used only two variables. So the degree is 1 and we have used two variables in both the equations. So it is linear in two variables. So what is non-homogeneous linear equation? So here in both the equation after the equal to we have different numbers. You can see in the first equation after equal to we have 8, and in the second equation after equal to we have 10. So they are different. So these types of equations are called non-homogeneous linear equations in two variables. So sometimes you may have after equal to 0 0. For example, if I am having equation like this, x plus 2y equal to 0 and 3x plus 5y equal to 0, then that is not a non-homogeneous equation, it is a homogeneous equation. We are not having that for study, but for a point I want to say, so I said that. And now example number 2, the right side you can see. So here also I have given three equations. In this three equation the power of x, y, z are all 1. So the degree is 1, so it is linear. And in all the three equations I have given three variables. So linear equation in three variables, and after the equal to we are not having same number, different numbers, and moreover all the entries are not 0. So it is non-homogeneous linear equation in three variables. Consistency of a non-homogeneous linear equations. If there exists a set of solution which satisfies the given homogeneous linear equation, then the system of equations is said to be consistent. Here the word consistent means solvable. The given equations can be solvable, and it will have either a unique solution or infinitely many solution that is based on the given equation. So whenever we have a set of linear equations, while we solve the equation we will have two different type of solution. If the equations are solvable, we may have two possibility. Either we may get a unique solution. Unique solution means only one solution we will have for the given equation, and other one is we may have infinitely many solution for the given system. The next one is if the given system of non-homogeneous linear equation fails to have a solution means, then the system is said to be inconsistent and has no solution. This means the given system of equation cannot be solvable. If you cannot solve the given linear equations, then you will not get a solution. Types of solutions in solving a non-homogeneous linear equations. So here we have three types of solutions. The first one is consistent and has unique solution. The second one is consistent and has infinitely many solutions. The third one is inconsistent and has no solution. So this slide shows us the diagrammatic expression or the diagrammatic view of the consistent has unique solution type. The right side of the slide you can see three equations. Each equation represents a plane. Plane means what? For example, if you take your classwork note or the board, the floor, the desk, the bench, all the plane surface are said to be plane, and each plane equation can be expressed with the help of three variables x, y and z. So like that only we have three equations on the right side of the slide. You can see x plus y plus z equal to 3. So this, let me take it as P1. P1 means plane number 1. You can see the blue color plane, and the second plane is yellow color, that is representing the second equation, and the third red color P3 plane is representing the third equation. So when you solve all the three equations, you will get exactly only one solution That means you will get only one value for x and one value for y and one value for z, and that is nothing but the unique solution. In the diagram also you can see all the planes, they are meeting exactly at one point, that is the corner point. It is like how our classroom corner will be. So like that, here the blue and the yellow and the red, the meeting point in the corner, so that thing is going to be the solution. So this is the diagrammatic explanation for this type. And now we are going to have consistent and has infinitely many solution. So like the same, here also we have this. Here all the in the diagram you can see p1, p2, p3, all that they meet throughout a line. That means on a line how many points we'll be having? On a line we'll be having infinitely many points. So it means that, so the three planes intersect at a line. So the line fully you are having infinitely many points, therefore you'll be having infinitely many solution for the given three equations in the slide. The next one, so inconsistent and has no solution. So here also I have given three equations, and the first equation represents p1, second equation represents p2, third equation represents p3. The three planes, they're not touching each other, so they are parallel, or they may be something just they are not touching each other. So when they meet only, we can say the system will have a solution. So here none of them is meeting, so it is inconsistent and has no solution. Now we are going to learn how to solve the non-homogeneous linear equation using rank method. So here the steps are there. So these steps will definitely help you to do the sum in an easy method. And now the first step, write the matrix equation. This we have learned in the last year itself in matrix inversion method. You may be remembering that. And the matrix equation. So we should express Ax equal to B. Second step, write the augmented matrix AB. This means you have to join the A and B matrix, and together you have to make a matrix. So it's a joint matrix of AB. So that's what they say it as the augmented matrix AB. Right. Third step is, after writing the augmented matrix, so we have to bring echelon form in A comma B. The AB matrix we have to bring by using elementary transformations. You know, echelon form, the triangular form of zeros we have to make. So in the last class we have seen that. So that we are going to apply here. And after doing that, step number 4, we have to find the rank of A. So in the last equivalent matrix, we have to find the rank of A separately and rank of A comma B separately. So the first 4 steps over. So now the verification process. So here in step number 5, the first thing we have to verify is, after finding the rank of A and rank of B, rank of A comma B, you have to check whether they are equal. Rank of A equal to rank of A comma B equal to n. So what is n? Number of unknowns. Number of unknowns is nothing but the number of variables. So in an equation, they will be giving 3 variables definitely. So x, y, z. So these 3 are the variables or the unknowns. So n value is 3. Mostly we will be having n value 3. So that's what they're asking you to check. Suppose if rank of A, that is row of A, and rank of A comma B, row of A comma B, and n, all the 3 are equal means, then you can say the system is consistent and has unique solution. Okay, now step number 6. So here, if row of A is equal to row of A comma B, rank of A and rank of A comma B, they are equal, but they are not equal to the n value. So it is less than the n value, that is number of unknowns. Then the system is consistent and has infinitely many solutions. Okay, the next one step you have to verify is this. If rank of A is not equal to rank of A comma B, then for example rank of A and rank of A comma B are having different values means, then the system is inconsistent and has no solution. Exercise 1.1, sum number 3 we are going to see. So you can read this question in your textbook. And now the given equations are x plus y plus z equal to 9 and 2x plus 5y plus 7 z equal to 52 and 2x minus y minus z equal to minus 6. Actually equal to minus 6. And that number is given as 0 in your textbook. You please change that. So this is minus 6. Okay. So now we are going to solve this equation by using the rank method. What the steps we have learned some time back, we are going to use it here. So we know the first step is what? The matrix equation. So using the equations, I'm going to write the matrix equation. You can see A x equal to B. I'm writing the coefficient matrix. The first equation coefficients are 1 1 1. The second equation coefficients are 2 5 7. Third equation coefficients are 2 minus 1 minus 1. And x is nothing but the variable matrix, we know very well. So what are the variables we are using? X, Y, Z. So I have written equal to the constant matrix. The last one is 9 52 minus 6. So this is Ax equal to B. This we know already. We have studied in the last year. And now the second step, the augmented matrix we are going to do, right? So the augmented matrix is the joint matrix of AB. So I'm going to take A and B matrix. I'm going to write it together. So in a matrix, I'm going to join A and B. So AB equal to first A matrix, then draw a line to understand it is separating A matrix and B matrix. It helps you to understand A and B entries. So A matrix, then a line, then B matrix. You can see that. And now step 3 is we have to bring the echelon form. So you know here while making the echelon form, we will make the second row first place 0 and third row first place and second place 0. So for that I am taking the transformation. R2 implies R2 minus 2R1. So R2 entries. The R2 entries are 2, 5, 7, 52 and 2R1. So multiply 2 in the first row and write. So 2, 2, 2, 18. So while subtracting we get 0, 3, 5 and 34, and that is to be filled in the second row now. So now the third row first place we have to make it 0. So here you can see the second row and third row in both places we have 2 2. So I can take this transformation. R3 implies R3 minus R2. So first I write the entries of R3. So 2 minus 1 minus 1 minus 6. Then R2 I am writing 2 5 7 52. Then I am subtracting. So I get the entries 0 minus 6 minus 8 and minus 58. So that will be filled in the third row now. So you can see. But yet this third row, the second place is not 0. We have minus 6. So we have to make that place also 0. So here we have minus 6. Just try to that in the second row we have 3. So we can make 3 as 6 easily by multiplying 2. So I am going to take the next transformation here. R3 implies R3 plus 2R2. Why I am using plus? Because here the one of the entry is minus, so the other must be plus. So that's why. So R3 implies R3 plus 2R2. So R3 is 0, minus 6, minus 8, minus 58 and 2R2. So multiply 2 in the second row. So you get 0, 6, 10 and 68. This time we are just adding. So add the entries. So you're getting 0 plus 0, 0, minus 6 plus 6, 0 and minus 8 plus 10, 2 and minus 58 plus 68, 10. So take this and fill the third row. You can see the green color arrow, and here I have made the echelon form, and this place I am marking with the green color arrow to understand. So here this is the last equivalent matrix. So after this we cannot solve. So only we say the last equivalent matrix, right? And it is in echelon form also. So after getting the echelon form, what we have to do? We have to find the rank of A separately and rank of AB separately. So how to find rank of A separately and rank of AB separately? Let's see. So in this one, for example, in the green color arrow matrix you can see. Now I'm going to hide B column I'm going to hide. So now you can see only A matrix. So in this matrix, the rank you are calculating now. So rank, how will you find? You will count the number of non-zero rows. Here in all the 3 rows, you can see non-zero numbers. So therefore rank of A is 3. Okay. Now how to find rank of A comma B? No problem. You just take include the B also with A. So now AB matrix. So in this, how many non-zero rows? We have 3 rows with non-zero entries. So rank of AB is also 3. That's all. And now n is number of variables. How many variables we are using? 3 variables. So here you can see rank of A comma B and n. All the 3 are equal. So therefore, we can say the system is consistent and has unique solution. So if the system is consistent and unique solution, you can find the unique solution. That means the values of x and y z value, you can find it. That's an easy one. Go to the last equivalent matrix, that is a green color arrowed last equivalent matrix. You go and take it and write it again. And now first, when the question is given, we made AB matrix, right? By writing the coefficients, we got the AB matrix. Now we are going to do it back. So we are going to use the back substitution method. That means from the matrix, we are going to create the equations. So you start from the last equation, that's the last row. That's why it is back substitution. The last row you can see 0, 0, 2 and that line, then 10. So 0, 0 means x coefficient is 0, y coefficient is 0, but z coefficient is 2. So I can multiply the 2 with z. So I'm getting this equation 2z is equal to 10. Say 2z equal to 10 means z equal to 5. Right, now let's go to the second row. So we have 0, 3, 5 and that's it, 34. That means there is no x term. We have y term, y coefficient 3 and z coefficient 5. So 3y plus 5z is equal to 34. Now already we know the z value 5. So take that and substitute in this place. So 5 into 5 becomes 25 and take it to the other side. So 34 minus 25 gets 9. So 3y equal to 9. So y equal to 3. Now, so in the same equivalent matrix, the first row you can see you have 1, 1, 1, 9. Right. So now here I am going to get the equation, that is 1x plus 1y plus 1z equal to 9. Already I found the value for y and z. So that is 3 and 5. I am substituting. So x plus 8 equal to 9. So x equal to 9 minus 8. So x value is 1. That's all. We got it. The answer for x is 1. The y is 3 and z is 5. And that is going to be the solution for the given system of equation. In this you could have understood one thing, that is the system has only one set of values for x, y, z. That's why it is said as unique solution. So hereafter, for your convenience to understand the concept of rank method, I am going to compile all the type of sums. So hereafter in this full video, we will be having only this type, consistent and has unique solution. So the remaining types we will be having in the next video. So this will be highly helpful for you. So the method is also same, the procedure is same, so we can get the idea quickly. So that's why. So now we will see exercise number 1.1 sum number 5. The three equations are given. So from that, first I'm writing the matrix equation. You can see the matrix equation is this. First we are writing the coefficients of x, y, z of all the equations in it. 1, 1, 1, 1, 2, 3, 1, 4, 9. This is A matrix, and X matrix is the coefficient variable matrix, that is X, Y, Z, and equal to the constant matrix 3, 4, 6 we are writing. So AX equal to B. We got it. And what is the second step? We have to write the augmented matrix. So I am joining A and B matrix here. You can see. So A and B matrix I have joined here. I have joined A and B matrices. So the augmented matrix is obtained. And now between A and B, we have to draw a line to understand A and B entries. Here I have drawn that. And now we have to bring in the echelon form. We know very well. So to bring the echelon form, what we have to do? In the second row, first place, we have to make it 0. And third row, first and second place, we have to make it 0. And here I can see the second row, first place is 1. I have to make it 0. So straight to that, in the first row also we have 1. So I'm taking the transformation. R3, R2 implies R2 minus R1. So R2 entries are 1, 2, 3, 4. And R1 entries are 1, 1, 1, 3. We are doing subtraction. So when you do the subtraction, you get answer 0, 1, 2, 1. Now fill the second row with these entries. And now on third row, first place also we have to make it 0. And for that, we are taking the transformation. R3 implies R3 minus R2. So R3 is 1, 4, 9, 6. R2 is 1, 2, 3, 4. So while subtracting, we get the entries 0, 2, 6, 2. Now take the entries, fill in the third row. So we got the second step. And now here you can see the second row is okay. Third row, first place is 0, but second place is still not 0. It is 2. Now we have to make the 2's place 0. So straight to that in the second row we have 1. We can make 1 as 2 easily by multiplying 2. So the next transformation I'm going to take is R3 implies R3 minus 2R2. So R3 is 0, 2, 6, 2. 2R2 means 2 you have to multiply in second row. While you multiply 2 in the second row, you get 0, 2, 4, 2. Now subtract it. So you're getting 0, 0, 2, 0. Now fill the third row. So we got the echelon form. That is the last equivalent matrix. So hereafter further we cannot solve it. So the green color arrow you can see. So this is the last equivalent matrix. So this is in echelon form. After finding echelon form, what we have to do? We have to find the rank of A separately and rank of AB separately. So that we are going to find. So now we will hide the B matrix. So now you can see only A matrix. We have 3 rows. In all the 3 rows, we have non-zero numbers. So rank of A is 3. Now let's join B with A. So we have AB matrix. So in all the 3 rows, now we have non-zero numbers. Therefore, rank of AB is also 3. Okay. Now n is number of variables, number of unknowns. We have 3. We are using 3 variables. So n is also 3. All the 3 are equal. So rank of A equal to rank of A comma B equal to n. Therefore, you can say the system is consistent and has unique solution. So if the system is consistent and has unique solution, you can find the solution. For that, you have to take the last equivalent matrix, the green color arrow you can see, and that echelon form matrix, that one you have to take again and write like this: AB equal to 1 1 1 3 0 1 2 1 0 0 2 0. That matrix you write by back substitution method. In reverse, you have to write the equations. So start from the last row. So last row we don't have x term, y term, we have only z term. The coefficient of z term is 2. So 2z is equal to, right side we have 0, so 0. So 2z equal to 0, so we get z equal to 0. And now in the AB matrix, the second row is 0 1 2 1. That means there is no x term, but we have y term coefficient 1 and z term coefficient 2. So 1y plus 2z is equal to 1. So already we got the z value 0. So that you just apply. So y plus 0 equal to 1. So you get y equal to 1. And now the first row we have to transform as an equation. So 1x plus 1y plus 1z equal to 3. Already we got the value for y and z. So that is 1 and the z value is 0. I am applying. So x plus 1 plus 0 equal to 3. So take this 1 to the other side. So it goes as minus 1. So we get x equal to 2. So now we got the value for x as 2 and y is 1 and z equal to 0. So therefore the solution is 2 comma 1 comma 0. Example number 1.12 we are going to see. The given equations are 2x plus y plus z equal to 5 and x plus y plus z equal to 4 and x minus y plus 2 z equal to 1. So the solution, the first step we know we have to write the matrix equation. So the matrix equation we are writing. So A matrix x equal to the B matrix. You know how to write A, x equal to B. And now the second step is we have to join the A and B matrix. So that is the augmented matrix. I have joined A and B matrix, and in between A and B we have to draw a dotted line or a line to understand the entries of A and B. So that's what. So augmented matrix we got. So this time in the augmented matrix, the first row, first entry is 2. Actually, that is not a problem, but if you have 1 in the very first place in the first row, it will be easy for you to do the calculation. So I am going to interchange the first row and second row. So R1 is interchanged to R2. So after interchanging, we get this matrix. So now after this equivalent matrix, we have to make the second row first place 0 and third row first and second places 0. So I can see in the second row first place we have 2. So I am going to take the transformation next. So R2 implies R2 minus 2R1. So the right side you can see the calculation. So R2 entries are 2, 1, 1, 5, and 2 R1 means multiply 2 in the first row and right. So 2 into 1, 2, 2 into 1, 2, 2 into 1, 2, 2 into 4, 8. So after the subtraction, we get the entries 0, minus 1, minus 1, minus 3. Now take that and fill in the second row. So like that, now we are going to do the transformation for the third row. So in the third row we have 1 in the very first place, so it's easy to do now. So we can directly do the transformation. So R3 implies R3 minus R1. So what is R3? 1 minus 1, 2, 1. So R1 is 1, 1, 1, 4. When you perform the subtraction, you get the entries 0, minus 2, 1, and minus 3. So now we got this, and take this and fill in the third row. So we got the first place 0 in second row and third row. And now after doing this, what we have to do now, this third row second place we have to make it 0. So actually we have 2 in that place, we have 2 in that place. So now that place we have to make it 0. Now take that and multiply with the second row and get it done. So R3 implies R3 minus 2R2. So R3 is entries are 0, minus 2, 1, minus 3, and 2R2 means take 2 and multiply in the second row. So you have 0, minus 2, minus 2, and minus 6. Now solving that, we get the answer 0, 0, 3, 3. And this is your new third row. Take that and fill the last row. So this is the last equivalent matrix. I have given the green color arrow mark, you can see. So after this you cannot apply any other transformation. So this is the last equivalent matrix. It is in echelon form. You can see the triangular form of zeros. So now we got the echelon form. So after the echelon form, we have to find what? The rank of A separately, the rank of A comma B, and n value. N value is 3, of course we know. So now we are going to find the rank of A. So how to find the rank of A? So to find the rank of A, you have to hide the B matrix. So you can see the 3 rows in A matrix. All the 3 are non-zero entries. Therefore rank of A is 3. And now you can join B with A. So you have AB matrix. Now also in all the 3 rows we have non-zero entries. Therefore rank of AB is also 3. So rank of A and rank of A comma B and n value all are equal to 3. That means all are equal. That means the system is consistent and has unique solution. So we can find the unique solution from the last equivalent matrix. So you take the last equivalent matrix, the green color arrowed echelon form matrix, and write it again, and in that you perform the back substitution method. You know that this matrix should be converted to the equation form. So take the last row at first. In the last row you can see the first the entries are 0, 0, 3. That means no x term, no y term. We have only coefficient for z, and that is 3. So 3z is equal to 3. So z equal to 1. And in the second row we have 0, minus 1, minus 1, and minus 3. So that is, there is no x term. We have only y coefficient and z coefficient. And minus y 1 y and minus 1 z is equal to minus 3. So we get this equation, minus y minus z equal to minus 3. We know the z value 1. Take it and apply in its place. After solving that, we get y equal to 2. And now the first row we have to focus. The first row we have 1, 1, 1, and 4. And now consider as a equation. So x plus y plus z equal to 4. You know the value of y and z. Apply in this y and z place. After solving, we get x equal to 1. So therefore the solution we get is 1, 2, 1. Now we are going to see example number 1.9, the same type. The given equations are x plus y equal to 5 and 2x plus y equal to 8. So in this sum, we have only two variables, that is linear equations, non-homogeneous linear equations in two variables. And now we are going to do the sum, the same procedure and the same method you can do. Just listen. The matrix equation is, so we know how to write the matrix equation. So first the coefficient matrix 1, 1, 2, 1. the next the variable matrix. So here we cannot write x, y, z because we have only two variables in the equation, so x and y. And now the constant side we have 5, 8, we got it. And now we got the matrix Ax equal to b. Now as usual the augmented matrix we are going to do, you join A and B matrix, so you get the augmented matrix AB, and in that we can have only the second row first place 0. We cannot make the first row first place 0, so in this time we have only one place that we have to make it 0, and that is second row's first place. So I'm going to take the transformation. R2 implies R2 minus 2R1, so the R2 entries are 2, 1, 8, and 2R1 means multiply 2 in the first row and right, so 2 into 1 2, 2 into 1 2, 2 into 5 10, we got it. And minus symbol I'm giving, so after subtraction we get 0, minus 1 and minus 2, and take it and fill in the second row, that is our new second row, so we got it. And after this you can see it is in echelon form. This time it is not in triangular form, but for this type this is the only possible way to get the echelon form, so this is the echelon form. And hereafter you cannot solve this also, so it is the last equivalent matrix which is in echelon form. So now we are going to find the rank of A. So to find the rank of A we have to hide the B column, so I have hidden the B column. Now in A matrix you can see we have two rows, in both rows we have non-zero entries, so therefore the rank of A is 2. Now to find rank of AB, see the full matrix AB matrix, and in this you can see there are two rows we have non-zero entries, therefore rank of A comma B is equal to 2. And here number of unknowns are 2. We are using only two variables x and y, therefore n equal to 2. So all the three values rank of A comma B and n value, all the three are equal, therefore you can see the system is consistent and has unique solution. And now we have to find the unique solution. So take the last equivalent matrix, the green color arrow matrix, and write it again. So AB equal to 1 1 5 and 0 minus 1 minus 2. So by the back substitution method you are getting the last row, so take the last row and convert as equation. So there is no x term, so we have only y coefficient, so minus y equal to minus 2, cut the minus on each side, so y equal to 2. And the next one, the first row in AB matrix is 1 1 5, so that is x coefficient is 1, y coefficient is 1, so x plus y is equal to 5. Already we know the y value, y is 2, so I am applying y2, y equal to 2, so I get x equal to 5 minus 2, so x equal to 3, therefore the solution is 3 comma 2. So exercise number 1.1, sum number 7. So before starting the sum, I want to give you an example. Suppose I am having a cash reserve of rupees 10,000. For example, if I am buying some product for 2,000 rupees, then what happens in my reserve 10,000, I have to less rupees 2,000. So whenever I purchase some products, my cash reserve is decreasing, so I have to use minus sign whenever I purchase the quantities, or for whatever the cash I buy, I have to put a minus before that. So I have purchased for 2,000, so I am subtracting from 2,000 from the 10,000, so minus 2,000 I am using. Okay, so whenever I sell any product, for example, if two products I am selling means for 5,000 rupees, then I will be getting 5,000 rupees on my hand. So it is an additional one to my cash reserve. Already I have 10,000. While I sell any product, I get 5,000 extra. So totally 15,000. So plus sign we are using. So keep in mind, for purchase minus sign, for selling plus sign. But now we'll see the sum. So question number 7. And they have given the question here. The price of three commodities, capital X, capital Y and capital Z. So capital X quantities price is X, and capital Y products price per unit price is Y, and capital Z's per unit price is small z. And here three people, Mr. Anand, Mr. Ramar and Mr. Amit, they are going to have some purchase, and that is given. And here the question I have constructed as a table here for you to understand better. So we will read first line and we come to the table and understand. So Mr. Anand purchases. I told you purchase means minus sign. Okay. Selling means plus sign. So Mr. Anand purchases 6 units of Z. So you can see here I have used Anand, Amir, Amit here, and here capital X, capital Y, capital Z, and the profit column at last. Here Anand purchases means minus sign, 6 units of Z. So in Z I have to put minus 6, and sells means plus sign, 2 units of X. So X below X I have to put 2 plus 2, and 3 units of Y, sells 3 units of Y, so plus 3. That's all. And next, Amar. Mr. Amar purchases means minus. Amar purchases a unit of Y. A unit means 1. So minus 1. Straight to Y, we have to put minus 1 for Amar. And then sells 3 units of X and 2 units of Z. So in X row, plus 3, and Y column, plus 2. And then Mr. Amit purchases a unit of X. So in Amit row, for X, we have to put minus 1, and sells 3 units of Y and a unit of Z. 3 units of Y, so plus 3, and sells a unit of Z, so 1 in the Z column. That's all. And in the process, they earn rupees 5,000. That is, Anand earns rupees 5,000. That is the profit. And Amit Amar earns rupees 2,000, and Amit earns rupees 5,500. So respectively, find the prices per unit of three commodities, that is small x, small y, and small z value they are asking. By rank method we are going to do. I hope you understand the question. So connect the question with the table, and from this table only we are going to have the equation. The first row, it is a equation. Okay, so now you see 2, 3, minus 6 and 5,000 we have. So we are going to have the equation, first equation, 2x plus 3y minus 6z equal to 5,000. And the second row is 3 minus 1, 2, 2000. So 3x minus y plus 2z equal to 2000. Like that, minus 1, 3, 1 equal to 5500. So minus 1x plus 3y plus z equal to 5500. So as usual. So here we got the equation. So now the matrix equation I have constructed. You can see Ax equal to B. And after the matrix equation, step 2 is we have to write the augmented matrix. So we are writing the augmented matrix. So I'm joining A and B matrix here. So A and B are joined. And here the first row, the first entry is not 1. So it is 2. So 2 is not a problem. If it is 1, it will be easy for us to calculate. So I'm going to interchange the first row and the third row. So R1 is interchanged to R3. Now we are going to do the calculation. So we have to bring the echelon form in this. So for that, the second row first place, and the third row first place and second place we have to make it 0. So let's focus now in second row first place. So here R2 implies R2 plus 3R1. I'm going to take the transformation. This time using plus 3R1 because R1 starts with a negative sign. That's why. So here R2 implies R2 plus 3R1. So R2 entries are 3, minus 1, 2, 2000, and 3R1 means multiply 3 in the first row and say, so minus 3, 9, 3, and 5000 into 3 becomes 16,500. So while adding we get the answer 0, 8, 5, 18,500. So I have filled the second row now, and third row first place also we have to make it 0. So for that I am going to do the next transformation. R3 implies R3 minus R3 plus 2R1. So R3 entries I am writing 2, 3, minus 6, 5000, and 2R1 means multiply 2 in the first row. So minus 2, 6, 2, and 11,000. 5,500 into 2 becomes 11,000. While adding we get 0, 9, minus 4, and 16,000. So take this and fill the third row now. So here you can see the second row and third row they started with the entries 0, 0. So now the third row second place we have to make it 0. But you see straight to the 9 you are having 8. So you cannot make 8 as 9 or 9 as 8. So we do one thing. I'm going to take 9 and I'm going to multiply the second row. I'm going to make the second row and the third row, the second entries, they are going to be the same numbers. So I am going to multiply the second row fully by 9. So when I multiply by 9, R2 implies 9 R2. All the entries I'm going to multiply by 9. So I get 0 into 9, 0, 9 into 8, 72, 9 into 5, 45, 9 into 18,500 becomes 1,66,500. Like that, the third row also I'm going to make a transformation. So R3 implies 8 R3. So when I multiply the R3 by 8, I get 0 into 8, 8, 0 into 9 into 8, 72, and minus 4 into 8, minus 32, and 16,000 into 8, 1,28,000. Like that we got it. And now you can see this one, and here still the third row second place is not 0, but now you can see in the third row second place is 72. Up to that, in the second row second place is also 72. So it is very easy. We can take the transformation. R3 implies R3 minus R2. So I'm writing the R3 row 0, 72 minus 32, 1,28,000, and R2 row also I'm writing 0, 72, 45, 1,66,500, and the transformation has a minus sign, R3 minus R2. So I'm applying minus in the R2 row. So when I subtract, I get 0, 0, minus 77, minus 38,500. So this is our new third row, R3. So it is filled in the last row now. So furthermore, we cannot solve this by any other transformation. So it is the last equivalent matrix. In this matrix we got the triangular form of 0. That means it is in echelon form. After finding the echelon form, what we do? We find the rank of A and rank of A comma B separately. So now I am going to find the rank of A comma B and the rank of A and rank of A comma B. So hide the B matrix. Now you can see only A matrix. So in the A matrix you have all the 3 rows with non-zero entry. Therefore rank of A is 3. And now include the B matrix also. Now you can see all the 3 rows with 3 non-zero entries. So rank of A comma B is also 3, and total number of unknowns, the variables used is 3. So n is equal to 3. And now, so we are going to solve this equation. So here we got rank of A and rank of A comma B and n, all the values equal. So you can say the system is consistent and has unique solution. So to find the unique solution, we have to take the last equivalent matrix. The last equivalent matrix we have to take, the echelon form matrix we have to take, and that we have to write again and write it again. And in this one, by back substitution method, we will from the last row I get the equation minus 77 is it equal to minus 38,500. When you divide by the minus 77 the other side, you get is it equal to 500. And the second row I'm going to convert as an equation. So I get 72y plus 45z equal to 1,66,500. So already I know the z value. I'm substituting. So 72y plus 45 into 500 equal to 1,66,500, and by solving that I get y equal to 2000. And now the first row in AB matrix I am transforming as an equation. So minus x plus 3y plus z equal to 5500. So in this also I am going to apply the y and z value. By applying and solving, I get the value x equal to 1500. So I got the value for x, y and z. So therefore the prices of the commodity is capital Y, capital Y and capital Z per unit is rupees 5,500, rupees 2000 and rupees 500. And now before seeing a sum, we need this hint. So we have learned this formula already. Simple interest equal to PNR by 100. That is price into n number of years into R, rate of interest, by 100. So here PNR by 100. So P is the principal. Principal means the investment. N is the number of years. R is the rate of interest. Okay, using this we are going to do a sum now. It is important 5 mark sum. So sum number 8 in exercise number 1.1. So here an amount of rupees 5,000 is to be deposited in 3 different bonds. bearing 6 percentage, 7 percentage and 8 percentage per year respectively. This number 6 percentage, 7 percentage and 8 percentage per year are the rate of interest for the three amounts you are depositing, right? Now the total annual income is rupees 358. Income means, so through the interest you're getting some amount, right? And that is said as the income here. If the income if the income from the first two investment is rupees 70 more than the income from the third, it is a hint to find the values. So they have given this, we'll see how to use it. Then find the amount of investment in each bond by rank method. Okay, let's get into the sum. Actually, I'm having 5,000 rupees for an example, right? And I have to split the 5,000 rupees into three amounts, and the three amounts I have to invest in different bonds, and each bond is giving me a different return. In the first bond, I'm getting rupees 6. I'm getting 6 percentage. In second bond, 7 percentage, and third bond 8 percentage, right? Like that. Okay, but I do not know what amount I'm investing. So that we have to find using the hint. And let me take the first amount as x, and second amount as y, and third amount as z. So let x comma y comma z be the amounts invested in three different bonds. Okay, so the total amount invested is equal to 5,000. What is total amount? The addition of all the amounts. So x plus y plus z equal to 5,000. So we got the first equation, right? The second one, the total income is equal to 350, 358. How will you get income? The income is obtained through the interest, that is simple interest. What is our simple interest? PNR by 100. So price into number of year into rate of interest by 100. So actually here we have three different bonds. So I will get the income from the first amount, second amount and third amount. So all the three I will be getting the interest. So here first we have to calculate for the amount x. So for the principal x, the rate of interest is 6. So 6 into the number of years you are investing is for 1 year. So 1 into x by 100, PNR by 100 plus, like that. For the second amount y, the rate of interest is 7. So 7 into, for 1 year you are investing 1, the investment amount is y. So y, 7 into 1 into y by 100, like that. For the third amount, the interest rate is 8. So 8 into, for 1 year 1 into the amount invested is z, so by 100. So we get the equation 6x by 100 plus 7y by 100 plus 8z by 100 equal to 358. In all that, the denominator is same. So I write 6x plus 7y plus 8z by 100 equal to 358. The 100 I cross multiply to the other side of the equation. So I get 6x plus 7y plus 8z equal to 35,800. This is the second equation. And in addition to this, they have given a hint in the question. It is given the income from the first two investments. Income from means the interest obtained from the first two amounts is 70 more than the third. Okay, let's see. The income from the first two means first amount's income, that already we have seen. 6 into 1 into x by 100 plus 7 into 1 into y by 100 is means equal to 70 more means 70 plus that than the third means the third amount, that is 8 into 1 into z. So we get 6x by 100 plus 7y by 100 equal to 70 plus 8z by 100. So while simplifying, we get the equation 6x plus 7y minus 8z equal to 7000. So this is our third equation. So now we got the three equations, and with this we are going to solve the equation. We are going to use the rank method. And now the three equations I have written, the system of equations are, we got the equations. And now directly I am writing the augmented matrix. Sorry, I have written matrix equation. It is augmented matrix. So 1 1 1 and 6 7 8, 6 7 minus 8 and the line, then the B matrix I am writing. And now I'm going to make the second row first place 0. So R2 implies R2 minus 6 R1. So the R2 entries you can see, the R2 entries are 6, 7, 8, 35,800. 6R1 means multiply 6 in the first row and say, so 6 into 1, 6, 6 into 1, 6, 6 into 1, 6, 6 into 5,000, 30,000. And we have minus symbol in the transformation. So when you put minus in 6R1 row, you get 0, 1, 2, 5,800. So take the row and fill the second row in the equivalent matrix. And now the third row, the transformation is very simple. So you can see the second row and third row, they are starting with 6. So we can use this transformation. R3 implies R3 minus R2. So R3 entries are 6, 7, minus 8 and 7,000. R2 entries are 6, 7, 8 and 35,800. When you put the minus sign, it changes the signs and you will be getting the answer 0, 0, minus 16, minus 28,800. So this I take and fill the last row. And here we got the triangular form of zeros, and furthermore we cannot solve. So this is the last equivalent matrix. It is in echelon form. So we have to find the rank of the matrices separately now. So first I'm going to find the rank of A. You can see rank of A. So in this one, all the three rows we have non-zero entries. So rank of A is 3. And now fully rank of A comma B is also 3, because all the three rows has non-zero numbers. Rank of A comma B is also 3, and n, total number of variables used, is 3. So all are equal, therefore the system is consistent and has unique solution. So this time we are going to write directly from the last equivalent matrix. So from the last equivalent matrix, that is the echelon form matrix, I am going to write the equation. The last row is 0, 0, minus 16, minus 28,800. So that I am going to construct as the equation. So minus 16 is equal to minus 28,800 I got. So by dividing we get z equal to 1800. From the second row we get y plus 2z equal to 5800, and we are applying the value for z. So we get y value as 2200. And from the first row I get the equation x plus y plus z equal to 5000, and by applying the y value 2200 and z value 1800, here we get x equal to 1000, and we got the amounts x, y, z. Therefore the amounts invested in the three bonds are rupees 1000, rupees 2200 and rupees 1800. So dear students, so please practice all these sums and write it in a separate note, then only it will be highly helpful for you. And do it, don't be negligent, and it will definitely help you in board exam. We have one 5 mark from this type. So please copy these all sums in your note and solve that, then only you can understand. Thank you.